Now, we say in our revision on factors and prime factors, we see first of all that a number which divides another number exactly is a factor of that number. In this scenario, we have an example. If x divides y without a remainder, then x is a factor of y. What do we mean by this x and y you are seeing here? This can be a variable, a number, be it 2. Let's say if 2 divides 4 without a remainder, which we know is true, then 2 is a factor of what? 4. So you pick x as a number and y as another number and use this. This is just like a model to the definition of factors. Now, any number that divides another number without a remainder, that is what we mean by exactly. Exactly means without a remainder is the factor of that number. If we say that 18 divided by 9 is equal to 2, which means that what? Both 2 and 9, or say 2 and 9, are factors of what? 18. Since 2 divides 9, 2 divides what? 18 to give us 9, and what? 9 divides 18 to give us what? 2. So we now say that what? Both 2 and 9 are factors of 18. Now, we have another example. If we say that what? 45 divided by 15 is equal to 3. It means that 3 and what? 15 are factors of what? 45. So these are numbers that can divide them exactly without remainder. Now, hello students. Now remember, when we talk about prime numbers, now prime numbers are numbers that have 2 words, factors. Now, these are numbers that have 2 factors. Now, what do we mean by these 2 factors? The factors are that's themselves and 1. And 1. Now, so let us make it a singular word now. We say that a prime number has 2 factors, itself and 1. A prime number has 2 factors, itself, the other itself, and what? 1. So, in this now, when we now talk about prime factors, we mean that 2 are factors of a number that are prime. That's what we mean by prime factors. Remember, in also in giving examples to prime numbers, we have 2, we have 3, we have 5, we have 7, we have 11, 13, 17, 19, even 23, 29, as case may be. Now, these are prime numbers which I have mentioned. Let me write some down. I say prime numbers, we have examples like, we have 2, 3, 5, 7, 9, 11, 13, 17, 19, 20, 3, 29, 31, even 37, even 61, as case may be. They are all prime numbers. Now, 1 we ask, 1, is it a prime number? Some books will tell you that 1 is a prime number, and 1 is called a pseudo-prime number. Pseudo-prime number. What makes it a pseudo? A pseudo means that it's just singular. It has nothing again except itself. That's why we say that one is what? A universal divisor. It divides every other number. Any number you can think of, one can divide that number, and it will still give you back that same number. So we call one a universal divisor, or it's also called a pseudo-prime number. Now, on prime factors, we mean factors of numbers that are prime. Factors of numbers that are prime. Once a factor of a number has no divisor, nothing again can divide that particular factor of a number. We say that that factor is a prime factor. So let's quickly look into some examples of prime factors. Now, let's consider factors of 18. You know, 1 is a universal divisor, 2, 3, 6, 9, and 18. These are factors of 18. They are the numbers that can divide 18 exactly without any remainder. Among these factors of 18, we have those ones that have no other divisor except themselves. We have this one, and this one. These numbers have no other one that can divide them except themselves. Now, also let us consider factors of maybe 100. 100 has factors like 1, 2, 5. Okay, let's have 4, 5, 10, 20, 25, 50, and what? 100. These are factors of what? 100. Among these factors of 100, there are ones that what cannot be divided by any other number except themselves and 1. And we have this. These are ones we call prime factors. They cannot be divided by any other number except themselves and 1. Now, let's talk about, we have a 63, or maybe let's say 63. 63, we have a 1, 3, 7, 9, 21, and what? 63. In this case now, the prime factors are this. These are ones that have no other ones that can divide them. So we now see here, they circled numbers in red are prime factors. Finding prime numbers using sieve of Eratosthenes. In this case, you are expected to draw a square, let's say 10 by 10. 1, 2, 3, 4, 5. Just make it up to 10. You continue to 10, 10, 11, 12, 13. Remember, you continue. This one will be 21, 22. You continue. You make it down to what? 91, 92. You continue to what? You get to what? 100. Now, this is what you mean by that. You are going to just draw a table like this, a 10 by 10 table. Then you are going to sieve the prime number. Just circle those ones that are prime.
Okay, okay, I know it.
Good. You first of all, any number, you start with the numbers that can be divided by 2. Those numbers that can be divided by 3 and so on. Those ones that you do not shade are the ones that are prime numbers. So let us not circle again. Before that, shade the ones that can be divided by 2 or except themselves. Like you start with 2. When you want to shade the number that can be divided by 2, don't shade 2. Start shading 4, 6, and so on. You know it before. This will be your work. Please, we would like to get your response on that. I will give you the process after now. Now look at the things you need to do. Remember earlier we told you that what? 1 is what? A pseudo prime. A pseudo prime number. So we cannot say that 1 is a prime number because 1 has no 2 factors. Prime numbers have 2 factors. Prime numbers have 2 factors, but 1 does not have 2 factors. Remember that. But 1 has itself. Now, note this thing. 1 is not a prime number. It is called a pseudo prime number. It is not a prime number really, because it has only 1 factor, which is itself. Numbers have 2 factors, itself and 1, but 1 has no 2 factors. So we are not going to count 1 as what? A prime number. In this process, you shade 1 since it is not a prime number as we said earlier. You shade all multiples of 2 except 2 because 2 is a prime number. Shade all multiples of 3 except what? 3. Now the same thing you also do for 5. Shade all multiples of 5 except what? 5. Now you also shade all multiples of 7, like 14, 21, 63. Multiples of 7 except 7. And this is the 5th one. The 6th one, you shade all multiples of 11, 13, 17, as case may be. Shade all multiples of 11, 13, 17, 19, as case may be, except themselves. So these are ways you can detect those ones that are prime between 1 and 100. You can extend it to what? 200. What you mean by prime factorization means expressing what? A number as a product of its prime factors. Prime factorization means expressing a number as a product of its prime factors. We've said what we mean by prime factors and we gave some examples. Now, when you express a particular number as a product of its prime factors, we call that process prime factorization. Now, we have our 18, which we talked about. Now, how do you, first of all, express this 18 as a product of prime factors? What we do is to continue to divide 18 with the least prime factor we have, which is 2. Remember, we said 1 is not a prime number. Now, 18 divided by 2, you do it this way, we have what? 9. What can divide 9? 3 is a next prime number that can divide, prime factor that can divide what? 9. Okay, we have 3. 3 divided itself gives us 1. So we are going to express 18 as a product of these prime factors. Now, we have 2 times 3 times 3.
Yes.
as product which can give us 18. Now, when we talk about 24, remember that 24 can mean 2 times 12. But 12 is not what? A prime factor of 24. So we are going to express this 12 more. Let's just open 12 again. This 12 can mean, this can mean 2 times, this 12 is 2 times what? 6. We're also going to open up 6 again, because 6 is not yet a prime factor of 24. So you're going to open up 6. 2 times 2 times 6 is what? 2 times 3. So we see that what? We have expressed 24 as a product of its prime factors. So this is what? The expression of 24 as a product of its prime factors. Form. If we are asked to express these values in index form, we can have them this way. Now, in this case, in index form, this is 2. We have only 1, 2, and we have 2 3s. That is this. So this is in index form. The power here for these 2 will be 2 here. So in this one also, in index form, it will be 2, 1, 2, 3. That is 0 to the power 3 times 3. This is the index form of this. So when they ask you, express a particular number as a product of its prime factors in index form, this is what you are required to give. Now, express 120 as a product of its prime factors in index form. In this case, you first of all divide through to get what the things that can divide 120. You know that in dividing to get factors of 120 or prime factors of that, we have 120. Starting to divide 120 to give us 60. 2 divide 60 to give us 30.
Yes.
2 divide 30 to give us what? 15. 3 can divide 15 to give us 5. 5 divided this one to give us 1. So we now have that 120 is 2 times 2 times 2 times 3 times 5. Now let's take it out. 2 times 2 times 3, 2 times 3 times 5. This is the prime factorization of this. And in index form, it will be 2 raised to the power 3 times 3 times 5. This is the expression of 120 as a product of its prime factors in index form. When you ask to express 444 as a product of its prime factors in index form, the first thing you do is to, first of all, divide through. We have 444. Let's start, since this is an even number, start with 2. 2 divides this to give us 2, 2, 2. 2 divides this to give us 1, 1, 1. 3 can divide this number. 3 divides 11, you are going to have 3 remaining 2. 3 divides 21, we have what? 7. And 7 is what? A prime, 7 is a prime number. No number can divide it. So we have our 444 to be, okay, 37 divided by 1. 2 times 2 times 3 times 37. So we have 2 raised to the power 2 times 3 times 37. So this is our value in this form. Now, when we talk about HCl, we mean the highest common factor. Now, in this now, let us look at numbers. Let's say 2 numbers, like we have 18 and 12. 18 has factors as 2, 3, 6, 9, and 18. These are factors of 18. And then we have 12 factors to be 2, 3, 4, 6, and 12. Among these factors, there are ones that are common. What do you mean by that term? Common. By common, we mean you find them here. You see these ones, they are common. The common factors are what? The common factors here are 2, 3, and 6. Among these common factors, 1 is the highest. Now, the highest common factor 6. You see it now. This is the highest common factor. All these ones, you see, you have here, you have here, you have here, you have here, this one you have here. Only this one is the highest of the common factors. That's how to detect highest common factors in or among what number. Let's just consider LCM. The LCM means the lowest common multiple. Now, you know what a multiple of a number means. Numbers that can be divided, or that the particular number can divide subsequent number of times. What we mean by like multiples? No, multiples of 2 means numbers 2 can divide. Multiples of 2 means numbers 2 can divide. So a number that can be divided subsequently by another number is the multiple of that number. Now we say, example, 2 has multiples of itself, 4, 6, 8, 10, all even fast. All even numbers. All even numbers is just a set. That is multiples of yes. Yes.
Uncle, please, what did you write? Where did you write under multiples of 2?
Okay. You say that what? Numbers means numbers 2 can divide.
Yes.
Numbers that 2 can divide, that's what we mean by multiples of 2. So we gave example. In fact, all even numbers are multiples of 2. Okay, when we have 2 numbers, say we have 6 and we have 8. 6 and 8. And say you should find their common multiple. What we are expected to do is to list out the multiples of 6 and list out the multiples of 8. Now, when you list out these multiples of 6 and 8, you're also going to get what? Numbers that you find in 6 and what? Multiples that you find in 6 and you also find them in 8. Those ones are ones we call multiples of what? 6, common multiples of 6 and 8. Among those common multiples, there's the one that is least in them all. That is the common multiple. Especially the first common multiple you find is the lowest common multiple. Now, assuming that we have some multiples of 6 to be 6, 12, 18, 24, 30, 36, and so on, and we also have multiples of 8 to be this. Now, what are their common multiples? There are multiples you find here, and you also find here, their common multiples are what? Let's pick the common multiples. You find them in 6 and you find them in 8. We have this one. We have this one, as case may be. Now we have 24 and 48, as case may be. Now, among these common multiples, the lowest of them all, the lowest common multiple is what? 24. So you see that now, you see how you detect or you can get lowest common multiples. When you list out the whole common multiples of this and this, you now pick out the common ones as we have 24 and 48. The least among them, the lowest among the common multiples is the one you pick as your lowest common multiple. There is another method which you use in getting this also, and that method seems to look shorter. In taking the other step or other method of finding LCM, we have 6 and you have 8. You use the least 1, 2 to divide, since they are all even numbers. 2 divide 6, we have 3. 2 divide this, we have what? 4. You keep on dividing with 2 until you are done with all equal numbers that are here. So 2 divide, 2 cannot divide, break it down. 2 divide this one, you have 2. 2 divide again, bring this one down, 1. Next one is 3. You must get 1, 1 here before you conclude. So what you now need to do is to multiply these ones out. Multiply them out. Multiply them out. So we have what? LCM to be 2 times 2 times 2 times 3, which is 2 times 2, 8 times 3, 2 times 2, 4, 8, and 24. So this is the second method which you use in getting the LCM of numbers. Remember, this is a class, a revision class on what we've done, what we did in our JSS1 as an entry revision class for JSS2 students. We need to revise all these things for you. So please take them down and ask us questions where you find confusing. So take these ones down as assignments, take your time and do them. We have given you this earlier in this class, so please try and use the sieve of Eratosthenes to find the prime numbers between 1 and 200. I gave you 100 earlier, so make it up to 200. You can rule a 20 by 20 matrix table and get that. In our next class, we are going to be looking into the rules for divisibility. The rules for divisibility. Don't make sure you don't miss the class. Click on the next video, you are going to see it. Rules for divisibility. We thank you for being part of today's class. Meet you next time.